Of course.
Do you mind?
Nope.
Oh.
Okay, let me just write here, starting at 3:05. Check, is this on screen? Yeah. I toch anyway edit this intro thing. Yeah, it's so difficult to do this like upside down. I keep forgetting to change that intro. So now, when people come on, it still says, today we're revising grade 10 exponents, so that you're ready for grade 11. So now I'm doing factorizing.
Did you restart it?
No, I'm changing it, but now I have to type while it's upside down, so it's very difficult. Okay, there we go. I'm gonna start writing some notes so long.
You don't eat?
I must still eat. Can make fish fingers maybe, she hasn't had that in a while.
Okay. Can show you.
Is it?
Oh, you like me?
Yeah.
Can do one.
I don't know if they can hear you, they can hear me, I'm sure. But it's fine.
Do people know that you are a Chelsea fan? That Matt's the favorite Chelsea fan.
No, they don't know that I'm a Chelsea fan.
Only because I bought.
But it was fine.
She knows some
Doesn't matter how it started.
She knows some place.
see if people have said some stuff so long.
That's my welcome. Sorry.
That's fine. Hate maths but love the handwriting. Yeah, I'm going to do grade 8 and grade 9 next week. I'm just reading some comments now. I do have a YouTube channel, yes. There's a link in my bio. I already did grade 11 in this past week. It is up on my YouTube channel, a recording of the live. It will be on YouTube, yes. Okay, 1 more minute, guys. Please share this video so that lots of people can join. Okay, it is 5 past. We're gonna get started. Okay, guys, welcome to this live. Thank you so much for joining. Today we are just going to be revising factorizing, the factorizing that you did in grade 9. You will be learning new types of factorizing in grade 10. I'm not going to do that today. We're just going to go over the grade 9 ones. You were supposed to learn 4 different types of factorizing in grade 9. You might have done grouping. You might not have. Don't worry about that if you didn't. We're not going to go over that today because it's almost like an extension thing in grade 9. But we are going to look at common factor, common bracket, difference of two squares, and then factorizing trinomials. Now, I just want to let you guys know that my phone is facing away from me, so I can't see your comments as I am, or your questions as I am teaching, but after each example, I will just quickly go and check your comments, and if there's anything that you ask me, I will just explain. I think just firstly, just to go over you guys, or go over with you guys on what you're actually going to be doing in the first, I think it's 3 weeks of grade 10. You are going to be doing algebra, but normally you start with the number system, which you might have already done if your school started on Wednesday. I'm not going to talk about that really in the live because it's mostly knowledge-based stuff, theory. You need to memorize the definitions. You need to understand how the numbers are all fitting together. I am going to teach it to my class, obviously, and then I will post that to my YouTube channel. So if you want a lesson on that, then you must just wait for, I'll probably do that on Wednesday or Thursday this coming week. But that is normally what you start with the number system, the different types of numbers and how they work together. Then after that, you should start by revising algebraic expressions. So just going over terminology like what is a term, what is a monomial, binomial, trinomial, things like that. And then you usually do products first. Now, products, maybe I should just write over here. Products is basically multiplying out. And multiplying out brackets mostly, that is the focus in grade 10. You are going to revise the products that you did in grade 9, where you have something like a 2 in front of a bracket, like an x plus y, and then multiplying that into the bracket, so you would get 2x and then plus 2y. So that would be the first type of product that you will revise. Then you will do stuff like binomial by a binomial. So remember, a binomial is something that has 2 terms, so like x plus y is a binomial and x minus y is also a binomial. So remembering how to FOIL these out. And I just said I wasn't going to revise this, but now I suppose I am doing it. All right, so you will FOIL these out. So you will say first times first, so x times x is x squared. Then you will do the outers, x times negative y is negative xy. Inners, so y times x is xy. And then L is for last, y times negative y is negative y squared. And then you see that you have like terms here. Negative xy plus xy is 0, so you will be left with x squared minus y squared. Alright, then some of you might have done this in grade 9 where you have, let me just look in this textbook quickly, where you have a binomial and a trinomial. So for example, you'll have x plus y, and then that would be your binomial because there are two terms in the bracket. And then you have your trinomial, so you can have, for example, 2x squared minus 3 plus y cubed. Alright, this is a trinomial, this bracket, because there are three terms. And what you will then do in this case is you need to take the x, so the first term in your first bracket, and multiply it by all of the terms in the second bracket. And after that, you're going to take your y, your second term in your first bracket, and also multiply that by all three terms in the second bracket. So I can just do that with you quickly. X times 2x squared is 2x cubed. X times negative 3, remember positive times a negative is a negative, and x times 3 is just 3x. Then you have x times y cubed, and now it's positive times positive, so that's why I'm putting a plus there, is xy cubed. Okay, so now we've taken the first term and we've multiplied it by all three terms in the second bracket, and that gave us those three terms. Now we need to do the same thing with y, and notice that it's positive y, so we're going to say positive y times 2x squared is just plus, let me just see if this is still on the screen. There we go. We're going to say plus 2x squared y. Alright, that's the product that we did there. Now we're going to say y times negative 3, so that's negative 3y. And then we're going to take y multiplied by the last term, so y times y to the 3. And it's two positives that I'm multiplying together, so it's plus, and y times y to the power of 3 is y to the power of 4. Now what we need to do is we need to look at all our terms. We have 6 terms now because we've taken 2 terms that we've multiplied by 3 each, so that gives us 6 terms in the end. Now we just need to check if we have any like terms, and in this case we actually don't. Alright, all 6 of these terms have different variables and different exponents of those variables, so this is actually the final answer in this case. Alright, so you're going to spend quite a lot of time on that as well. Then you will just, I'm not sure what textbook you guys use at your schools. I'm sure it's all different. We use Classroom Maths where I teach. So then at the end of doing all these separate types of products, we always do one exercise where you have a bunch of them mixed together. So you'll probably do that. And then you move on to factorizing. So yeah, I've just done a very quick revision of product. I hope that that is fine. They can obviously become a bit more complicated depending on, you know, they can do like fractions, or they can do more terms, I suppose, or yeah, the terms can be more complicated in the sense of how you are multiplying it out, but that's basically what you'll do in the first bit. Okay, then we get to factorizing. Let me just move this again. Okay, and I have prepared some examples already so that we can just get going. I've listed the different types of factorizing. What is important to remember is that they often mix them together. Alright, you'll see as we're going further down, so like this example here is a mixture of two types of factorizing. Yeah, they can often mix them together. So whenever you are getting a question and they're asking you to factorize it, you need to first check whether there is a common factor. Okay, we'll get to all of that now. I just want to remind you guys that, let me use a red pen instead, it will be a bit clearer, I think. Factorizing is the opposite of multiplication. right? So when you are multiplying out, like we saw in these examples that we looked at now, the question when you are asked to multiply out, when you are asked to find a product, the question that they give you in all of these examples is one term. In the sense that 2 multiplied by a bracket, that is one term altogether, all right? This is 2 terms. The answer consists of 2 terms. So when you are multiplying out brackets, you are going from one term to multiple terms. And you can see that that happened in all of these cases. The next example, also one term. Remember when you have 2 brackets and you're multiplying them together, that is one term. And the answer that we got in the end was 2 terms. So we've gone from one term to multiple terms. Here in this case, the question again was one term, a bracket multiplied by a bracket, and the answer consisted of 6 terms. Right, so when you are multiplying out brackets, you are going from one term to multiple terms. Now when you're factorizing, you're doing the opposite of multiplying. So you are going from multiple terms to one term. And that is actually the purpose of factorizing. Just writing that down, going from multiple terms to one term. That is actually why we learn how to factorize, so that we can do that. So that when we are working with algebraic fractions, which you will do later on at the end of this chapter, you will have to use factorizing as a tool in order to change multiple terms into just one term so that you can cancel out. Alright, if that confuses you, don't stress. You will do it in class and I will do videos covering it as well. But that is actually the purpose of factorizing. So that is something that we need to remember. That factorizing is so that you can go from multiple terms to just one term. In other words, our answers here are going to have one term. Alright, they will possibly be something like a number or a variable in front of a bracket, or maybe 2 brackets written next to each other, maybe more than 2 brackets written next to each other, but it will have to give us one term. Okay, I'm just going to check in on the comments quickly, see if I've missed anything. I see there's some people answering questions for me on here. Thank you for that, guys. Yeah, someone asked if I can give you examples, questions that you can do on your own at the end. I will do that. I will put up an exercise for you. Okay, I'm going to get going. All right, so common factor. Now guys, something that is also important, and we're going to discuss it quite a lot as we are doing all of these questions. Remember I said here that factorizing is the opposite of multiplying. Now, if you think of it in that way, what mathematical operation is the opposite of multiplying? Right? Multiplying is when you multiply 2 things together or multiple things together. The opposite of multiplication is division. So when we factorize, that is actually what we do. Okay, so that's maybe a nice way of remembering it. That factorizing is the opposite of multiplication, multiplying, so it is dividing actually. Alright, that is important. So when we are looking at these first types of examples, the first type of factorizing is common factor. So that is basically, remember, we want to factorize, so we want to go from these 2 terms to just one term. At the moment we have 2 terms, we want to go to just one term. So now we need to look at these 2 terms and we need to see, do they have something in common? Is there perhaps a number that can divide into, remember factorizing is actually division. Is there a number that can divide into both of these terms? Right? Once we've figured out whether there's a number that can divide into both of them, then we start looking at variables. Okay, we take it one step at a time. So if we're looking at the numbers, we have 6 and we have 10, right? I think that you all can notice that 2 will divide into 6 and 10, all right? So 2 is a common factor of this of both of these terms. So I'm going to write that down. Okay, and in this case, that is also the highest common factor. There isn't a number bigger than 2 that can go into 6 and 10. Okay, it's not the end of the world if there was a bigger number and you didn't notice that at first. I'll show you maybe with the next example. You can factorize using multiple steps. You don't have to do it all in one step. Okay, so here 2 goes into 6 and 10. And then do we have the same variable in these two terms? Not in this case. Okay, so 2 is the common factor. Now what you do is you write that common factor, then you put a bracket next to it. And remember, what did I say? Factorizing is actually division. So now we're going to have to take both of these two terms and divide it by the common factor. Okay, we tend to say that we take out a common factor, but that's not really mathematically correct. Okay, that's just a way of speaking. Actually, we are dividing by the common factor. That's what factorizing is, dividing. So now we're going to say 6x divided by 2. 6 divided by 2 is 3, and then there's an x left there as well. Now, we're going to put a minus there because the next term is negative. Now we're going to say 10y divided by 2 is, 10 divided by 2 is 5y. Notice that we now have one term. We have a 2 multiplied by a bracket. Remember that multiplication and brackets, they don't separate terms. Okay, so when we have a number or anything in front of a bracket, it means that it's being multiplied by that bracket, so that is just one term. What is important though is that if you started with 2 terms, you have to have 2 terms in your bracket. Okay, so that is important here. Let me see. We started with 2 terms, and now inside the bracket, you also have to have 2 terms. That's a nice way of checking whether you have actually factorized correctly. Another thing that you can do is, remember, factorizing is the opposite of multiplication. So if you now multiply this bracket out, you are supposed to get the same thing that you started with. Don't write that down though. Okay, this is your final answer. You need to leave this as your final answer. You can just do it quickly in your head. You can say, what is 2 times 3x? It's 6x, good. Minus 2 times 5y is 10y. All right, but don't write that down as a next step. That would be wrong. Okay, that's just a check to see whether you factorized correctly. Okay, I'm just going to read comments quickly. Okay, guys, I'm not going to talk about the difference between maths and maths lit now. I'm doing this. I will make videos in the future on that rather. Okay, next up, next example, we see that we have 3 terms. Okay, and now we need to factorize. So we need to firstly check for a common factor. So we need to see, is there a number, is there a certain power of A, of B, or of C that will divide into each of these 3 terms. All right, so we see firstly that there's no number written here in front. We know that that means that there is actually a 1. Okay, so that this is actually 1a squared b cubed c squared. You can put that 1 there if you want to. You don't have to. Same thing here. This is a negative 1, and there we have a 2. Okay, so we don't actually have a number that will divide into all 3 of these, except for 1. 1 will divide into all 3 of them, but then we're not going to write that. Okay, so now we're looking at the a's. In the first term, there's an a squared. Next term, there's an a. Third term, there's an a cubed. All right, so now what is the highest power of a that will divide into all 3 of these? It's just a. Okay, so basically the highest power of a that appears in all 3 terms, and that is just a to the power of 1. Okay, now let's check for b. We have a b cubed, b squared, and another b squared. So the highest power of b that appears in all 3 of them is b squared, because there's a b squared there, a b squared there, and a b cubed, and b squared will divide into b cubed. So b squared is going to be a part of my common factor. And then I have c squared, and c to the 4. And again, we see that the highest power of c that divides into all three of these terms is c squared. Alright, so that is my full common factor. Now we're going to put a bracket there, and now we are going to, remember, factorizing is division. We're going to divide each term by this, by the common factor. And we're going to do it one variable at a time. Okay, don't try and do it all at once. If you're a bit iffy with algebra, you can do it just one variable at a time. So for the first term, we're going to say, what is a squared divided by a? That is just a. Then you're going to say b cubed divided by b squared is b. Then we have c squared divided by c squared. Anything divided by itself is just 1. Alright, so there actually will be no c's left if I take my first term and I divide it by the common factor. So this is what's left from the first term if you divide it by your common factor. Okay, next term I'm going to put my minus. Now we are going to take the next term and divide it by the common factor. Again, you can do it one variable at a time. So you can see a divided by a is 1, b squared divided by b squared is 1, c squared divided by c squared again is 1. Or maybe you notice that this whole term is actually your common factor. Do you guys notice that? This term is a, b squared, c squared. The common factor is also a, b squared, c squared. And anything divided by itself is 1. Guys, you have to put that 1 there. Right? You can't just say that, oh, I'm now dividing it so there's nothing left. When you divide something by itself, 1 is left. Okay, so you have to put that minus 1 there. If you don't have it there, then it's actually wrong. Next up, plus. Now we have a 2 here divided by what number is here in front? Actually a 1, right? We didn't write it. You can if you want to. 2 divided by 1 is just 2. Okay, now we're going to do a cubed divided by a is a squared. B squared divided by b squared is 1, right? Anything divided by itself is just 1, so there are no b's left. Then we have c to the 4 divided by c to the 2, c squared. So that will give us c squared, and then we can close our bracket. Notice that we have now gone from 3 terms to 1 term, but we started off with 3 terms, so in our brackets we need to have 3 terms again, which we do have. Okay, I'm just going to add that as well. So we started with 3 terms. Oh, I think I must just check if this is on screen. I'll check that now. Oh, it's a bit off. There we go. Okay, something that I forgot to say in this example, but I can just say it now that we're looking at both, is that if, for example, you just took out a as a common factor here, right? A is a common factor of these 3 because a does divide into all 3. So that's not wrong. It's just an incomplete common factor because a is not the only thing that divides into these 3 terms. Okay, so if you do that, that's okay for your first step. Then you would just have to divide each term by a. But then when you have your bracket, when you have stuff here in the bracket, you will see that in those terms, you again have common factors. Okay, maybe I must just do that quickly. Let me just rewrite this example. So we have a squared, b cubed, c squared, minus... Sorry about the paging back and forth. A, b squared, c squared, plus 2a cubed, b squared, c to the 4. Okay, I just want to show you guys what will happen if you don't take out the highest common factor at the beginning. Alright, like I said, it's not the end of the world. You will then just have to do extra steps. So, let's say we just say that A is the highest common factor. Okay, we don't feel like checking B's and C's for now. We just notice that A goes into all 3 of them. Now we're going to say this whole thing divided by A. So now we just have A squared divided by A. That is A. But then B cubed and C squared, if I divide that by A, it's not going to cancel anything out, so I will be left with that. minus, if I take this whole term and I just divide it by a, the a's are going to cancel out. I'll be left with b squared c squared, and then plus 2a cubed b squared c to the 4. I'm just dividing it by a. I will be left with 2a squared b squared c to the 4. Now guys, this is factorized, but it's not fully factorized. You'll notice when you get factorizing questions, they'll always say factorize fully, all right? Because you can argue that this is factorized. You have divided by a common factor, but it's not fully factorized, because if you look at the three terms that you have in your brackets, there actually are still common factors here. B squared will go into all three of these terms, and c squared will also go into all three of these terms. So if you notice that, then you can just put the rest of the factor that you are now noticing in front next to the a. All right, so if you now see that, okay, yes, a was a common factor, but actually b squared, c squared is as well, you can just add that to the a, and then you just need to remember that that is now the bit that you've taken out, that you're dividing by. Then you can divide each term now by b squared, c squared. And you will then be left with the same thing that we started with, 2a squared, c squared, like that. Okay, obviously this isn't the best way of doing it. It's just, yeah, sometimes you won't notice everything that can divide into your terms. You might need to take a second look. So I suggest that when you have taken out a common factor, just check whatever is in the brackets to see if you can maybe factorize it again, especially later on when you get more complicated questions where you actually factorize according to one type, and then whatever is in your brackets maybe is a difference of two squares, but you must then factorize again. Okay, we'll look at an example like that just now. Okay, I'm just going to read some comments quickly. Diane, it's not wrong. You get to the same answer in the end. You will get full marks for that. This is pure maths. I am going to save the live and I will put it on my YouTube. Okay, so someone asked here, why did I write -1? Because if you have this term, the middle term there, negative ab squared c squared, and you now divide it by ab squared c squared, the answer is -1. So you have to write that -1 there in the bracket. Oh, someone asked if I can take a picture of the, I suppose you mean this page that I'm writing on, and post it on my Instagram. Yes, I will do that. Thank you. That's a good idea. Okay, let's carry on to common bracket. All right, now common bracket is actually also a type of common factor. It's just a slightly different type, maybe a little bit more complicated. But if we look at this first example, which is 3a times p minus 3q in brackets, minus 2b times p minus 3q in brackets as well. I hope that you guys can see that we have the same bracket in both of these terms. This is one term, that is our second term, and in each of these terms we have the same bracket. Okay, so that is why we call it a common bracket. And when we now need to factorize that, that is what we're going to divide by. That is the common factor, like here we wrote a 2 in front of the bracket. Now we're just going to put the whole bracket in front of the second bracket. So actually when we factorize this, we are going to end up with 2 brackets next to each other. Right, which you did last year. It shouldn't seem too foreign to you. So in this first example, I'm going to take out p minus 3q as a common bracket, and you have to keep it in brackets, please. Remember, guys, the purpose of factorizing is to go from multiple terms to one term. So if you leave off these brackets here, then you're not going to have one term. All right, then it will still be multiple terms. So you have to take the common bracket and write it in brackets again. Now, next to that, we are going to take each term, and remember, factorizing is division, so each term we are going to divide by the common bracket. Now, it's easier to visualize this when you are dividing by a common bracket because you can kind of just cover the bracket up and see what is left. So if we're looking at the first term, we have 3a multiplied by this bracket. So if I cover up this bracket, if I take away that bracket, I divide by that bracket, I will be left with 3a. Then for the next term is negative, so I need to put a minus there. Now if we're looking at this term, again, I'm dividing by this bracket, so if I just cover it up with my pen, I can see easily what will be left, 2b. Alright, and that is the final answer. Let's just check each individual bracket and see that we actually have factorized fully. If we're looking at p minus 3q, is there a common factor in that bracket? Is there something else that I can take out from p minus 3q? No. And then when we have 3a minus 2b, same thing. All right, there isn't another number or a variable that will divide into the 2 terms in this bracket, so it is fully factorized. Okay, the next one is one that is slightly more tricky. Because if we are looking at these 2 brackets, firstly, I'm hoping that you guys can notice that there is a 2 in both of these terms, right? So 2 is actually a part of my common factor as well. But then I have an x minus y bracket and I have a y minus x bracket. Now, guys, these 2 brackets are very similar, but they're actually not the same. The reason for that is because x in this term, in this bracket, is positive x. In this bracket, we have negative x. So it's a different sign. In the first bracket, we have negative y, but in the second bracket, we have positive y. So we have the same variables in these 2 brackets, but they have different signs. It's positive x versus negative x, and then negative y versus positive y. So if I can do something to change the signs, for example, in my second bracket, if I can change this positive y to a negative y, and this negative x to a positive x, then I will have the same 2 terms. I will have the same bracket. Now, we call that a switch around. Okay, a switch around. And what you do in a switch around is, in order to change the signs inside the bracket, you also change the sign in front of the bracket. Sorry, my baby is a bit upset in the room. I don't know if you guys can hear her. I apologize. All right, so for switch around, change sign in front. I just want to see, it's a bit off screen. There we go. Change sign in front, and then that will allow you to change the sign inside the brackets. Okay, so we're going to leave this 2a squared times x minus y as it is for now. We're not actually factorizing yet. I first need to do the switch around. Now a switch around works like this. Instead of plus 2b, I now need to change the sign because, guys, remember, this is all one term. Okay, so the sign of the bracket is actually the sign of the 2b that's in front of the bracket. This is all one thing together. So there's a plus there. This is a positive term. So I need to change it to a minus 2b. And then I can switch around the order of the terms in the bracket. Right? It was positive y, it's now negative y. It was negative x, it is now positive x. Now guys, the reason why this works is, let's see, maybe I should just do it on a different page quickly. Okay, I'm going to write, just see. So we started with 2b times y minus x. Right? I have now changed, it was positive, so there was a plus in front. I have now changed it to negative 2b times x minus y, like that. Now guys, these two expressions are actually the same. They're just written differently. Let me show you why. If I multiply this 2b into the bracket, right? If I take positive 2b times positive y, I'm going to get 2by. If I then take positive 2b times negative x, I'm going to get negative 2bx. Right? So I've just written this expression differently. I've just multiplied the 2b into the brackets. Okay. I'm going to do the same thing for the switch around version, the version that I have now switched. Remember, I changed the sign in front of the bracket and then I switched around the terms. Essentially, I've changed the positive y to a negative y and negative x to a positive x. Let's multiply this out and see if we get the same thing. Negative 2b times positive x is negative 2bx. And negative 2b times negative y, remember a negative times a negative is a positive, and 2b times y is 2by. Now guys, I hope that you can see that I have the same two terms. In this top expression, which was the given one, the way in which it was given in the question, I have positive 2by, I have positive 2by in the switch around expression as well. Then I have negative 2bx and negative 2bx in the new expression. So these two expressions are actually equal to each other. I have just written it in such a way that I actually end up with a common bracket. Okay, so I'm just going to run through that again quickly, just the method there. Now I can underline them because now they are the same. So if you are noticing that you have two brackets that are very similar, but they have different signs, all right, so this one is x minus y and the other one is y minus x. They have the same variables, but they have different signs. Then you need to do a switch around. You could have switched around this one as well. It's just kind of common practice to switch around the second term, but it's fine if you did it with the first term. But I've decided to switch around the second term, so plus 2b becomes minus 2b, and then y minus x becomes x minus y. All right, now we have the same term, the same common factor, the same bracket. Now I'm going to write that bracket in front. All right, the x minus y and x minus y. Oh, I forgot something because remember we actually circled the 2's as well, hey? This question is quite tricky because it does not only have the bracket common, but also the 2. Okay, so 2 is also common here. Then we have x minus y. Do we notice that? 2 is in both of them and the bracket. So now this is a little bit more tricky, but it helps because we've underlined the stuff that we are now dividing by. We've underlined the common bits. So if you take your first term and you take away the stuff that's underlined, the 2 and the x minus y, I hope you guys can notice that I'm left with a squared. So that goes into my second bracket. My next term is negative, and if I take this term and I divide it by the common factor, which was a 2 and the bracket, I'm left with that b. Okay, now we just need to check x minus y. Is there something that I can take out from there? Is there a common factor in that bracket? No. And a squared minus b. No, I can't factorize this either. So that is actually fully factorized. That is the final answer. Okay, this is a tricky example, a tricky question, so don't feel too bad if you were a bit iffy on that. But yeah, hopefully that made sense, and hopefully you will be able to apply that switch around on your own as well. Okay, I'm just going to read comments quickly. It will be on YouTube, yes. Okay, user 690AB, then you better leave, hey, and go do something that's worth your time. Thanks. You're welcome. Okay, next up, difference of two squares. Now guys, a difference of two squares is a different type of factorizing, and just on the other page I just want to show you quickly where the method actually comes from. Remember, you are going to be doing products first, so this kind of stuff will be fresh in your memory when you do factorizing in class. I just want to remind you guys quickly, if we're looking at this middle one, right, we've actually already done an example like it. If we're looking at that one, the one that I am just bracketing in green. Right, we had two brackets that we multiplied together. In these two brackets, we had the same variables, right? An x and a y. The first bracket had a plus, the second bracket had a minus. Okay, now when we multiplied them out, because it was the product of two binomials, we used the FOIL method. So we did first, outer, inners, and last. Alright, we multiplied that out and then we simplified. And guys, now looking at it, do you notice that our answer is actually a difference of two squares? Remember, what does the word difference mean? The word difference means that you are subtracting. You're finding the difference between two terms. Alright, so difference, so there's a minus, and both of those terms in my answer are squares, meaning that they have square roots. Okay, so x squared has a square root. The square root of x squared is x, and y squared also has a square root. The square root of y squared is y. Okay, so we have two terms. Both of these terms have square roots, and we're finding the difference between them. So x squared minus y squared, this is a difference of two squares. Now, in this example, when I did it right at the beginning, we multiplied out. Okay, we multiplied two binomials out. Now remember, factorizing is going in the opposite direction. So starting with an x squared minus y squared and going to these two brackets. Okay, so that is where the rule for factorizing a difference of two squares actually comes from. It's because it is the opposite of multiplying out two binomials. So then when we have to factorize it, when we have to divide it basically, we need to go the other way around. We need to go from our answer here to the question, which was two binomials. If we look at what is inside these binomials, we have the square roots of the x squared. The square root of x squared is x. We have the square root of the y squared. And in the one bracket, we have a plus. In the other bracket, we have a minus. Okay, so that is what we're going to do. That is what we're going to do every time we factorize a difference of two squares. So I actually have that same question here, x squared minus y squared. With a difference of two squares, you are always going to get two brackets. Oh, now I'm doing this in black. I actually wanted to do it in red. Okay, let me just go over there. Excuse the sounds of my little girl playing in the background. Alright, so it's a difference of two squares. Firstly, you need to identify it as a difference of two squares, right? That's important. So you see, okay, I have two terms. There's an x squared. This thing has a square root. There's a y squared. This also has a square root. And there's a minus in between them. Guys, if there was a plus in between them, you couldn't factorize it. Okay, you couldn't factorize it like this. So there has to be a minus in between them. So now you're going to say, okay, we end up with two brackets. In both of these brackets, the first terms in these two brackets has to be the square root of the first term. So the square root of x squared is x. So that goes into both of my brackets. The square root of y squared is y. There we go. That goes into both of my brackets. And then I need to do a plus in the one and a minus in the other. Okay. Now, like we did with the previous questions, just check both of your two brackets, see whether you can possibly factorize either of them again. X plus y, I can't take out a common factor there, there's nothing I can do, and x minus y, same thing, so this is fully factorized. Okay, so that's a simple one. This example is actually just the reverse of the product example that we did at the beginning. Okay, remember, factorizing is the opposite, the reverse of multiplying out brackets. Okay, now this one is a bit more complicated in the sense that you can see that it's written under the heading of difference of two squares. But if we're looking at this question, yes, we have two terms. Yes, there's a minus in between them. But does 2 have a square root? Right? It has a square root of 2, but that is an irrational number. Okay, it has to have a whole number square root for it to be seen as a square. So if this was a 4x squared, for example, that would be a square because the square root of 4 is 2, which is a whole number. But because it's a 2x squared, it doesn't have a whole number square root, so it doesn't classify as a square. The same thing with 32. 32 actually also does not have a whole number square root. Okay, so neither of these two terms are squares. Now remember right at the beginning when I said that when you are getting factorizing questions, you need to almost go through like a checklist and first check, is there a common factor? Next up, is there a common bracket? Next up, is it a difference of two squares? And finally, is it a trinomial? Some of them you will be able to identify very easily, immediately. Alright, but that is not always the case. Sometimes here, you first need to check, okay, it kind of looks like a difference of two squares, but when you actually look at the numbers, you should see that it's not a difference of two squares. But I have a common factor of 2. 2 will divide into the first term, and 2 will divide into the second term. Alright, so here we actually start out by just taking out a common factor of 2, dividing by the common factor of 2. So when we do that, remember we write the 2 in front, we open our brackets, then we say 2x squared divided by 2 is x squared, then minus 32 divided by 2 is 16, there we go. Now, like I've been saying all the time, we need to check the bracket after we factorize, because we have factorized now. We've taken out a common factor of 2. After we've done that, we need to again check this bracket, the x squared minus 16, and see whether we can actually factorize again. So again, you need to go through your checklist. Is there a common factor here with x squared and 16? No. Is there a common bracket in this bracket? No. But if you look at these two terms, if you look at this bracket, you should notice that we actually now have a difference. Sorry about the dog barking as well. We now have a difference of 2 squares in that bracket that we just now created. Let me just move it up a bit. There we go. Oh, goodness. Alright, difference of 2 squares here in the bracket. So now, guys, we can't leave it like this because this is not fully factorized, because we have to factorize the bracket. Sorry, I'm trying to shield the phone from the dog barking. My apologies. Alright, so next step, we're going to keep that 2 where it is because it is a part of the expression. Right? We can't just ignore the 2. We have to keep it there, but now the x squared minus 16, we now have to factorize because it is a difference of 2 squares. Sorry guys, let me just close the door. Okay, my apologies. You can still hear her, I'm sure, but it might be a bit better. Okay, so now when we do a difference of 2 squares, we take the square root of x squared. What is the square root of x squared? X. That goes into both brackets. The square root of 16 is 4. That goes into both brackets. Then we put a plus in the one bracket and a minus in the next. Okay, now when we check these two brackets, we should just make sure, can I factorize again? If I have x plus 4, there's nothing I can do there, no common factor. X minus 4, no common factor. And now, guys, this might almost look like a difference of 2 squares, but that is an x. Okay, if that was x squared minus 4, then this would be a difference of 2 squares. Then you would have to factorize a third time. Okay, but in this case, it's fully factorized. We're done for that one. Right, let me just read the comments. Thank you, Audrey. I just saw your message. That's nice of you to say. FOIL stands for first, outer, inner, last. Oh, I see someone answered it. Thank you. Algebraic. Oh my goodness. Yes, I suppose that is what the dog is doing. Oh, there's so many comments. I can't get through all of them. Guys, I will do other grades as well. I've already done one on grade 12 and one on grade 11, but I'm only starting school this coming week, so I'm not sure what my schedule is going to be like, so I can't schedule anything yet. But once I know, like, when my sports and my extramural stuff is on, then I'll be able to schedule. Okay, I have now decided that I'm just going to do this last question still, and I think I must do a separate live on trinomials, or maybe I'll record a YouTube video on Monday. I'm going to have some time on Monday. I'll record a YouTube video on trinomials because it can get quite complicated and I don't want to rush it. Alright, it will also still be quite a while until you actually get to the point of doing trinomials at school in grade 10. I know this thing is like skew. Hello everyone, sorry my phone overheated and I didn't realize. We'll just wait for some more people to join again, and then I was almost done with this question when I realized that it closed. We'll just start this question again. Let me just mirror this. No. Oh, that is fine. Please share this video again if like friends of yours were on and you now are seeing that they're not anymore, so that they can just join again. Okay, I'm just going to wait for like 2 minutes, just make sure that everyone's back on. Okay guys, we'll get started again. I'm not sure how many people were on when it switched off. Sorry about that. My phone overheated, so TikTok closed by itself. And I didn't realize, I'm not sure how long it was off for by the time I realized. Okay, so I was busy working through this example. I don't know how much of it you saw. So I'm just going to get going just right from the start. Sorry, I'm just waiting for things to settle down a bit outside.
Close the window.
Sorry. Okay, so just a reminder that we are factorizing here. Okay, so we're supposed to factorize this, and we were working on difference of two squares. So if we're looking at these two terms, right, we have two terms. It's 81c squared and then negative 49d minus e squared. We need to go through all the steps. We need to first see, is there a common factor, all right? And in this case, 81 and 49, there is no common factor. With c squared and d minus e squared, also not. Next up, we're going to check for a common bracket. Now, since there is no bracket even in the first term, there can't be a common bracket. Then, next up, we're going to move on to a difference of two squares. Now, this looks very complicated, but if you just look at all the parts that make up these two terms, you'll see that all of those parts have square roots. So 81 has a square root of 9, c squared has a square root of c, 49 has a square root of 7, and d minus e squared, right, a bracket squared, the square root of a bracket squared is just the bracket. So all of the parts making up these separate terms have square roots, so these are classified as squares. So this is in fact a difference of two squares. Okay, now remember, with a difference of two squares, you have two brackets. I'm using square brackets just because we have round brackets there already. So I'm using square brackets. Then what you do is the first term in your two brackets when you factorize is the square root of the first term here. So the square root of 81 is 9, and the square root of c squared is c. So the square root of 81c squared is actually 9c. Alright, and we know that because 9c times 9c will give you 81c squared. Okay, so that works out. Then you're going to put a plus in the one bracket and a minus in the other bracket. Now we need to find the square root of this term. Right, now I'm just circling that. The minus is a part of that term, I know, but for finding the square root, we don't look at that minus. The square root of 49 is 7. And then the square root of a bracket squared is just that bracket, which we need to keep in brackets. Right? Now that might look a bit strange, but what I'm saying is that the square root of 49d minus e squared is 7d minus e. We can check that. Let me just do that here at the bottom. 7d minus e multiplied by 7d minus e. 7 times 7 is 49, and d minus e times d minus e is d minus e squared. Alright, so we do get that. Now, unfortunately, when you are factorizing, you are not allowed to leave your answers. You're not allowed to have brackets within your two brackets. Okay, so these two d minus e brackets we need to get rid of, which might seem like a bit of a schlep. It might seem a bit unnecessary, but in terms of getting full marks, you do have to now multiply out the 7s here. Alright, so now I can drop my square brackets. I can now make them round. So 9c plus 7d, because 7 times d is 7d, and then 7 times negative e is negative 7e. In the next bracket, we again have 9c, and now we do negative 7 times d is negative 7d, and negative 7 times negative e is plus 7e. And this now is the final answer. That is the final factorized expression. Just checking comments. Okay, so that is that one. So guys, this was a difficult difference of two squares, but still a difference of two squares. And what is important is that no matter how complicated the terms get, you still just find the square root of the one term, put that in both brackets, the square root of the second term, put that in both brackets. You have a plus in between the two square roots in the one bracket and a minus in between the two square roots in the second bracket. And then if you have any brackets within your factorized brackets, that you would then just have to multiply those out. Okay, I just want to do one last one. If you weren't on the first part of the live, I said that I was going to do trinomials, but I'm actually going to do separate TikTok videos and possibly a YouTube video on that on Monday, because I don't want to rush that. And yeah, my phone keeps overheating, so I want to get done with this. Let me just see, there's some more messages. Yes, I am going to do one more example. I'm going to do a to the 8 minus 1, which is a bit of a strange example. Someone also asked for mixed examples. I'll post a video just now on my TikTok with some mixed factorizing questions. And then tomorrow also I'll post answers to those if you want to practice what we've just learned. Alright, so a to the power of 8 minus 1. Just like with any other factorizing question, you need to go through the steps. Firstly, is there a common factor? No. Is there a common bracket? Definitely not. Then you check, do I have a difference of two squares? Alright, now we have two terms with a minus in between them, so the difference part is taken care of. Now these are funny terms. You might not notice that there are squares straight away. Alright, but a to the power of 8 actually does have a square root. The square root of a to the power of 8 is actually a to the power of 4. I don't know if you guys remember this from grade 8, but when you have the square root of a variable that has an exponent, could even be a number with an exponent actually, then you take whatever that exponent is and you divide it by 2. That is how you get the square root. So the square root of a to the 8 is equal to a to the 8 divided by 2. That's how you get that. Alright, so a to the power of 8 does have a square root, yes, so it is a square, and 1 also has a square root. The square root of 1 is just 1, so 1 is also a square. Okay, so now we're going to follow our difference of two squares steps. We're going to put our two brackets there. We're going to put the square root of the first term as the first term in the two brackets. So the square root of a to the 8 is a to the 4. We put a plus in the one and a minus in the other, and the square root of 1 is 1. So that goes into the one bracket and to the next. Now we need to check our brackets. I've said before, we always have to check our brackets to see if we've factorized fully. The first bracket is a to the 4 plus 1. I can't factorize that. But if we're looking at the second bracket, 4 minus 1, this again is a difference of two squares. Just like in the example up top, we had x squared minus 16. Which was a difference of two squares, which we had to factorize. Now, a to the power of 4 minus 1 is again a difference of two squares. So I need to factorize that. I'm going to write my a to the 4 plus 1 just as it is. We can't factorize that again, but we have to keep it there. It is a part of our answer. Now we're going to factorize a to the 4 minus 1. Alright, so the a to the 4 minus 1, which is a difference of two squares, now is going to be factorized to two brackets. The square root of a to the 4 is a to the power of 2. That goes into both brackets. You put a plus in the one, a minus in the other. The square root of 1 is 1 again. And now, again, this last bracket, a squared minus 1, again is a difference of two squares. So again, I have to factorize that. I just want to check if this is on the screen. Yes. Okay, so now again, a to the 4 plus 1, we can't factorize, but it's still a part of our answer, so we have to write it there. a squared plus 1. We also can't factorize. These are both squares, but that's a plus in between them. So this is actually a sum of two squares, and we can't factorize that. This a squared minus 1, I now have to factorize. It's a difference of two squares, so again, it's going to give me two brackets. The square root of a squared is a. That goes into both. The square root of 1 is 1. That goes into both. So one bracket gets a plus and the other bracket gets a minus. And now finally we are done factorizing, because now my minus bracket, which could possibly be a difference of two squares, a is not a square. Alright, if it was a squared like up there, we could factorize this, but now it's just a minus 1, so it's not a difference of two squares anymore. Okay, I'm just going to read some comments quickly. So we factorized a to the 4 minus 1, not plus 1. The minus 1 we're factorizing because this is a difference of two squares. A to the 4 plus 1 we can't factorize because it's a sum of two squares and there is no way of factorizing that. Alright, so I'm just rewriting it every time because it is a part of the answer, but I'm not factorizing that one. A to the power of 4 minus 1 I factorized into these two brackets, and then the last bracket, which again was a difference of two squares, I now factorized into those last two brackets. Alright guys, I'm going to call it there. Like I said, I'm going to make some content for you guys on trinomials, so just be on the lookout for that. And in the next 5 minutes, I'm going to post some questions on factorizing on my TikTok, and then tomorrow I will post the worked solutions to those. And yeah, I will see you guys around. Keep an eye out for when I announce more lives. I will be going live. I don't want to make any promises, but I will be going live again for grade 10 and for the other grades as well. And I am always posting content on my TikTok and also on my YouTube. I'm going to start recording lessons on Wednesday of this coming week, and those will be up on Wednesday afternoon. So just keep an eye out for that. Thank you so much, guys. Have a good day. I will post it on YouTube, yes.